Okay. So the first theorem we have is theorem 4.1, which says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Which basically means if you have an isosceles triangle, then the base angles are congruent. We have, yeah? I am. So we have then three corollaries to this theorem. Corollary 1 says if you have an equilateral triangle, it must be equiangular. Corollary 2 says an equilateral triangle then must have three 60-degree angles. You know this because they would have to add to 180 and they're equal, and maybe divided by 3 is 60. Corollary 3 tells us that the bisect or the vertex angle of an isosceles triangle will be perpendicular to the base at its midpoint. Theorem 4.2 is the converse of theorem 4.1. What it says is if you have two angles in a triangle congruent, then the sides opposite those angles must be congruent. Yes, and gentlemen. Converse means that you take the part that's after the if and the part that's after the then, and you switch the places. So theorem 4.1 said if the sides opposite triangles are congruent, or otherwise if you have two sides congruent, then the angles opposite those sides are congruent. So we kind of just switch those positions. We have one corollary to theorem 4.2, and that is that an equiangular triangle must also be equilateral. So we're going to be using these theorems and corollaries. Let's do a couple of examples. If you look at page 137 in the book, what we have is a triangle with sides of 10 and 10 and 12. You have a 74-degree angle and an x, and you want to know what is x. Well, first off, is this triangle isosceles? Yes. Which means that the angles opposite those sides must be congruent. So how do I find x? So I go 180 minus 74, and that gives me 106. What will divide by 2? So x is going to be 53 degrees. Now, going the converse then. Let's see if we can find one where it's the converse. I'm going to jump to page 138. And what I want to do is take a look at problem number 23. Number 23, I have a diagram that looks something like this. See if I can do this. It's kind of at an angle. And we have these sides all congruent. We have the angles numbered 1, 2, 3, 4, and 5. And they tell us on number 23 that angle 1 is 20 degrees. So measure of angle 1 is 20. They want us to find the measures of 3, 4, and 5. So if angle 1 is 20, what other angle has to be 20? 2. 20 degrees.